Alright, chapter 9 review again, number 1. So what it's asking us to do is to just technically just flip stuff around. So what we did, we used the reflection rule, which means that we would leave one of the axes alone and change the other one. For example, since this is on the x-axis, we would leave the 3 alone and change this to the opposite number. I'll show you an example right now. Our answer for A prime is 3 and -2. And then we do the same thing for B prime. We changed it to -8, -1. Bam. Alright, number 2. It's asking us the coordinates of W after a reflection of the x-axis. Basically, it's the same thing as number 1. We just have to use the reflection rule. So, all we have to do is just switch 3 to the opposite number. So, W prime would be 5, -3. Done. No? Yeah. Alright. Problem 3. Determine how many lines of symmetries the object has. As you can see, this is the Batman symbol. So all we have to do is draw a line wherever and see what happens. Basically, the line of symmetry is like a mirror. So you just got to make everything look alike. So obviously, this looks alike because they're both the same image. But what happens if I go this way? It's not going to look right because these two don't look alike. So our answer would be we only need one line of symmetry. Problem number 4. Basically, it's the same thing as number 3. We still have to put lines of symmetry. So what we do is what we do. Draw the item in half. It looks alike because they both reflect. What about if I do it this way? Yeah, because these two are similar. It's the same thing. Problem 5. Which transformation is best described in the figures shown? So, what we got was translation. Basically, translation is like moving an object here and down. That's pretty much it. Alright. Problem 6. Which object does not exhibit rotational symmetry? Obviously, 8 ball is obviously 1 because you can rotate it twice. Obviously, the recycle logo, of course you can. You can keep going. Now for the triangle with the equal legs, obviously, you can only go once though. So the answer would be B, because even though I turn it this way, it's not going to look the same until I do an all 360 turn. So the answer is B. Problem 7. Pretty much this is just using vectors. So the vector that we have is A vector equals, it says 1, -2. Meaning we go 1 to the right since it's a positive, and we go 2 down. That's how we solve the problem. Now I know this looks a little complicated, but it's simple, obviously. So what you do for this problem is you add 2 with the x. So for y, we would put, since it's -1 over 2, and then we add this problem to that. So that would equal 2 1 -3. And we go all the way down here. This is our y prime. 1 -3. Same rule applies for a z. So what you do is you add 2 to the x-axis, which is 5. Then you subtract 5 with the y-axis, which is 2. Whoops, oopsie, sorry. And we just move it down here, and that'll be our z. Alright, number 9, we have to find the translation rule that moves from cat triangle to dog triangle. Pretty easy, actually. All you have to do is just pick any one, because they're gonna go the same route. And you just go to the right. All you have to do is add 5 to the x, and add 4 to y. So 1, 2, 3, 4, 5. 1, 2, 3, 4.
Alright, so basically what we got to do is the question is looking for Q, and Q is right here. So basically what we got to do is we got to turn the graph 90 degrees counterclockwise, so the graph is going this way. So we basically have to turn this whole graph on the other side. I'm not going to do it right now. So basically what you do is you have the point right here, so that's negative 8 and 2. So what you do is you do what they do in the graph. So you go by negative 8 and then 2. So this is Q. That's it. Basically, this is an enlargement thing. So basically, this is the old one, this is the new one, as it says. You count how many squares it is. So that's 2 on the top and 2 on the bottom on the sides. And you go to the new one, that's 4 and 4. And then you put in this equation, new over old. So the new one is of course 4 by 4. So you just simply pick any one you want. So you pick 4. Old one has to be the same. So you pick 2. And what that equals is 4 over 2 is 2. So the new one, the new one is twice as big as the old.
Problem 12. Now this, it may not look like it, but it's a photo. We'll just call it the box. Now it was originally measured 11 by 9. And then it was later enlarged to a size of 55 and 45. All we have to do is find the scale factor. It's pretty much the same thing as number 11. So that means that this is the old one, and this is the new one. We already knew that. So all we have to do is put in the scale factor, which equals new over old. So it doesn't matter which one, because it's still going to be the same number, obviously. So we'll pick 45 over 9, which equals 5. That's your answer.